So in this video, we're going to talk about the standard score, also known as the z-score. This is very important because we're going to use z-scores later on in the class and until the end of the course, like from chapter 5 on, right? So z-score represents the number of standard deviations. A value x lies from the mean mu. So how do I find it mathematically? It's z equals the value minus its mean divided by the standard deviation. And how is this represented on your formula sheet? It's going to be x minus mu divided by sigma. Okay? So the mean speed on Highway 69 is 60 miles per hour with a standard deviation of 5 miles per hour. So based off that information, we got two things that are important. Look at your two numbers, right? So the mean speed is 60 and the standard deviation is 5, okay? So this is going to help us get our z-scores. So you're sitting on the side of the highway and you measure 3 cars that drive by. One person's driving at 48, one person at 61, and the last person at 68. I want to find the z-score for each speed. So how do I do this? The z-score is equal to the value minus the mean over the standard deviation. So before I do anything, I know that the mean is 60 and the standard deviation is 5. What is the first value? The first value is 48. So I do 48 minus 60 divided by 5. What do I get? Negative 2.4. The next one, z equals what? What's the next one? 61 minus 60 over 5. This gets me a positive 0.2. And the last one is 68 miles per hour. 68 minus 60 over 5. This gets me 1.6. Now, what do these numbers mean? How do I interpret negative 2.4? So the negative 2.4, that means that I'm negative 2.4 standard deviations below the mean, okay? So technically, I'm 2.4 standard deviations below. That below is where that negative's coming into play. So what does this mean? This means that I'm traveling unusually slow. Now, how do I know it's unusual? Anytime I'm 2 or more standard deviations away from the mean, that is unusual, okay? Now, what about 0.2? That means that I'm 0.2 standard deviations above the mean. How do I know I'm above? It's a positive number, okay? And so I'm traveling close to the average speed. I'm traveling close to the average speed. 0.2 is not too far away from the mean. And then 1.6, that's a positive 1.6, so that tells me I'm 1.6 standard deviations above, because it's positive, the mean. All right? So that's faster. 68 is faster than driving 60, right? But it's not unusually fast because it's not 2 standard deviations above the mean. So you're traveling faster, but not unusually fast. If you think about it, if you're going 68 miles an hour, you might get pulled over by the cops. However, you might not, because it's not completely unusual, okay? If your average speed is 60 with a 5 mile per hour standard deviation. Now, if the standard deviation is smaller, that changes things, right? So it just depends. Okay, so graphically, what does this look like, all right? So can I have a z-score equal to 0 Can I get a z-score equal to 0 where I'm zero standard deviations away from mean? Yeah. If I'm going 60 miles per hour, then I am exactly on the mean, and so 60 minus 60 over 5 gets me 0 for a z-score. So how do you get a z-score equal to 0? You're going the average. Your value is equal to the average. That's how you do it. So my z-score on a chart, 0, 1, 2, 3, -1, -2, -3 standard deviations away. Okay, so the way I think about this is 60 miles per hour, and 1 standard deviation away, 1 standard deviation is 5 miles per hour. So that puts me up at 65 this way and 55 down that way. Puts me to 70 here, 75 there, 50 over here, and then 45 down here. Now, if you think about it, if I'm 2 standard deviations away, all right, I'm in this range right here. So it's usual score in this range. So 50 to 70 miles per hour would be the usual. That's like using empirical rule. If this was mound shaped, it would be like 95% of all things. Now, if it's we don't know the distribution, then we use Chevy-Chev's, and I think that's like 75%. Okay? But if we're outside of this range, all right, so we're outside of the range, meaning we're going slower than 50, okay, but we're going faster than 70, that's unusual. This is unusual. Okay, now there's an even more extreme. If I'm going slower than 45 and I'm going faster than 75, and faster than 75, this is very unusual. Very unusual. And if you remember, 3 or more standard deviations is very unusual. 2 or more standard deviations is just unusual. Now, guys, if you are very unusual, I think you would also be considered unusual. Okay, so don't let that throw you off.